Today we're going to talk about acid-base balance, something you don't really see, but it's happening constantly in the background. So to begin, the body keeps its pH within a very narrow range because even a small change in pH can affect how the entire body functions. At its core, this all starts at the cellular level. Every cell in the body is constantly producing energy, and as a result, it produces carbon dioxide as a waste product. Now we're going to talk about where CO2 comes from. That carbon dioxide enters the bloodstream, and once it's in the blood, most of it is converted into bicarbonate, which acts as a buffer to help control acidity. So even though we talk about CO2 and HCO₃ separately, they're actually part of the same system. Here's the core idea. So the body is constantly dealing with acid being produced, and it has two main ways to keep things balanced. The lungs remove CO2 quickly, and the kidneys regulate bicarbonate more slowly. The reason this system is so important is because the body's processes only work within a very narrow pH range. If pH shifts too far in either direction, it starts to affect enzymes, the heart, and the brain. Here's our key values. This is important. The normal ranges for pH is 7.35 to 7.45. CO2 is 35 to 45, and HCO₃ is 22 to 26. So first we're going to talk about respiratory, so connected to CO2. If breathing isn't effective, CO2 is not removed properly, so it builds up in the body, which increases acidity. This is respiratory acidosis. This can happen in conditions like COPD, hypoventilation, or respiratory failure. Here's an easy way to think about it. Not breathing enough, acid builds up. If someone is breathing too fast, they remove too much CO2, which lowers acid levels. This leads to respiratory alkalosis. This can happen with anxiety, pain, or hyperventilation. Here's the simple pattern. Breathing too fast, lose acid. Here's the primary exam emphasis. This is the gold. These patterns are important to recognize because questions will often describe breathing changes, and you'll need to connect that to whether CO2 is increasing or decreasing. On to the metabolic stuff. HCO₃ is bicarbonate, and it acts as a buffer for acid. So when bicarbonate is lost or used up, there's nothing to neutralize the acid being produced. This leads to metabolic acidosis. This can happen with diarrhea, DKA, or shock. In diarrhea, the body loses bicarbonate, so the buffer is lost and the acidity increases. In conditions like DKA or shock, the body produces excess acid, which uses up bicarbonate. It's ultimately the same result, low HCO₃ and increased acidity. This is a very common test pattern, especially diarrhea, DKA, and shock, leading to metabolic acidosis. Now we're going to talk about metabolic alkalosis. In metabolic alkalosis, the body loses acid. This commonly happens with vomiting or excessive antacid use. Why? Because vomiting removes acid, leaving more base behind. For the memory, vomiting is alkalosis. Vomiting leading to metabolic alkalosis is another very common pattern you'll see in questions. So to bring it all together, when you're thinking about this, focus on the patterns and the cause, not just the numbers. At a basic level, CO2 reflects the lungs, HCO₃ reflects the kidneys, and both work together to maintain the pH balance. Here's a clinical tie-in. These imbalances show up in real conditions. Lung problems affect CO2, metabolic or kidney problems affect HCO₃, and conditions like shock or infection often lead to metabolic acidosis. In some cases, the body will try to compensate, meaning one system adjusts to help correct the imbalance, and understanding how to recognize that pattern is what we'll cover in the next video. And one last point, this is an important one. This system is all about balance. How the body maintains stability, even as things are constantly changing. And when you really look at it, most things in life have to stay within a very narrow range to function properly. For example, if gravity were even slightly different, or the distance between the Earth and the Sun were off, life as we know it wouldn't exist. There are a lot of small variables, even right now, that have to be precisely maintained for life to continue. And when you start to think about that, it points to something beyond just random chance, but to order, structure, and design. Scripture puts it this way: and he is before all things, and in him all things hold together. If you're interested in that side of things, I've made some videos on it as well.